All right, today we are talking about conditional statements and conditional statements and related conditional statements we want to be able to understand very well. So conditional statements are used in English a lot. They are great. You know, structurally, conditional statements are great. They're great for when you grow up and have kids of your own. A conditional statement is the best way to parent, okay? So, for example, when you put on your jacket, then we can go outside. That is a great parenting statement, okay? So that's a when, then, all right? Also known as, if you put on your jacket, then we can go outside. So an if-then statement is a conditional statement. A conditional statement is a statement that can be written in if-then form. If, comma, then. If you eat your dinner, then you can have dessert. That's a good one, right? Yeah, Or when you eat your dinner, then you can have dessert. All right. So these are great parenting statements, and they're also mathematical statements. And so just like yesterday, we like to use letters to represent them. And so we have this symbolic form, P arrow Q. P arrow Q we read as if P, then Q. So you can imagine there's a little if there, and the arrow means then. If P, then Q. We can also say P implies Q. That if you successfully eat your dinner, am I going to give you the dessert that I promised you? Yeah. Okay. So if you eat your dinner, then I promise I will give you dessert. Okay. So it's sort of an implied promise when we say these if-then statements. And so mathematically, if you do the first thing, if the first thing is true, then the follow-up will also be true, okay? And that's important to know. So the hypothesis, E-S-I-S, the hypothesis, that's an H. I don't know what I was writing, but it was supposed to be an H. The hypothesis is a phrase that immediately follows the if. So it's the hypothesis. What comes after a hypothesis? Conclusion. Okay. All right. The conclusion is the phrase that immediately follows the word then. So, for example, identify the hypothesis and conclusion in the following conditional statements. If you live in Nashville, then you live in Tennessee. What's the hypothesis? Yeah, right here, following the word if. So you live in Nashville. All right. What's the conclusion? Yes, you live in Tennessee. You live in Tennessee. So the if, we have a hypothesis, the then gives you the conclusion. Pretty easy. Do we need to do any more? It's pretty easy, right? Yeah, okay. All right. So what's important about these conditional statements is that some things are not written in an if-then form. And so we want to be able to write conditional statements. We want to write each statement in if-then form. And you can see an obtuse angle has a measure greater than 90 degrees. Do you see an if and then in there? No, but it is an implied conditional statement. And so what we want to do is we want to be able to rewrite it so that it is an if, comma, then form, okay? So how could we do that? How could we sort of rearrange this statement and make it an if, comma, then conditional? that is very close. But I want to start with the obtuse part. Which is a little harder. I like what you did, but I want to start with the first thing. So if an angle is obtuse, all right, so there's the startup. If an angle is obtuse, if, comma, then what? Then its measure is greater than 90 degrees. Then its measure is greater than 90 degrees. Perfect. Okay. Let's look at number 5. All numbers divisible by 4 are also divisible by 2. How can we write that using an if? Yes, if a number is divisible by 4. If a number is divisible by 4, comma, then it is also divisible by 2. If a number is divisible by 4, then it is also divisible by 2. All right? What about number 7? Valentine's Day is in February. Yes, if it is Valentine's Day, then it is in February. It is February. All right, very good. Okay, are we okay with writing if then conditionals? If it, that's a it. If it is Valentine's Day, then it is February. All right, so if, comma, then, this is a conditional statement. Okay, great. So we also have related conditional statements. So related conditional statements, now these are actually important for us because we are going to be learning, and already have learned, quite a few theorems, like the theorem, if two lines are perpendicular, then you have 4 right angles, okay? If you have perpendicular lines, then you have a right angle. That is a conditional statement. It's a theorem. And what we can do is, you okay over there, boys? Okay. All right. So we also have some related conditionals that are going to take those theorems and turn them around for us, and we can use them in other ways as well. And so our original conditional was P implies Q, where P was the hypothesis and Q is the conclusion. If P, then Q. Well, we can also write the inverse. We can also write the inverse of our original conditional, by negating the hypothesis and conclusion. What does negate mean? Not. So all I have to do to write an inverse statement is to negate the hypothesis and conclusion. Symbolically, we would say not P implies not Q. And so all we have to do is insert a couple of knots. So the inverse is like the exact opposite, okay? It is a little squiggle. And on Delta Math, it looks like that.
Oh.
Yeah, it's just the opposite. It's not. So yeah. I'm sorry. It's a tilde, which I always do opposite how it should be, but it doesn't matter. It's a squiggle. All right, like that. So not P implies not Q. So that'd be like if you don't eat your dinner, then you don't get dessert. All right, that's the inverse statement. You don't eat your dinner, you don't get dessert. All right. They mean the same thing, but reversed, right? Like one's the positive side and one's the negative side. Which one's your kid going to respond to more? Negative. You think? If you eat your dinner, then you get dessert? Negative. If you don't eat your dinner, then you don't get dessert?
It's more like a punishment.
Interesting.
You get punished for not
eating.
See, but it's the same thing both ways, right? But which one's the happier phrase? The first one's the happier phrase, right?
I feel like if you were just like yell at them, oh, no,
The first one makes it sound like
Yes, it does.
You eat your dinner and you're going to get that.
Yeah, yeah. It sounds, one way sounds like a reward and one way sounds like a punishment. Isn't that interesting? But they mean the same thing, right? Oh, gosh, it's crazy. Okay, okay. So there's the inverse statement. We add in some knots. Now, the converse, so you know you got your Converse sneakers. Who has Converse sneakers? I'm not a fan. I'm a Vans girl myself. But you got your Converse sneakers. I like to think about when you got your Converse sneakers, they originated in basketball, okay? They were designed and built for basketball. And so when you're in basketball court, on the basketball court, those shoes are designed for you to be able to switch direction really fast, okay? And that's what we do when we're talking about the converse statement. The converse, we got to switch. We are formed by switching the hypothesis and conclusion, okay? So we got to switch back. So we say Q, God bless you, if Q, then P. All right? So the converse, we got to switch. You got that? Is that going to help you remember? All right, so converse, we got to switch the P and the Q. And then the contrapositive is formed by negating and switching. It's really the negation of the converse. So it's not Q implies not P. So it's negating the converse is how that works. So what we want to do is do a little bit of practice here, figuring out what is what and how to write it. So the directions, write the inverse, converse, and contrapositive of the following conditional statement. Determine the truth value. If false, provide a counterexample. All right, let's see what we got here. So here is our conditional statement. If it is Saturday, then there is no school. All right. So first of all, is this a conditional statement? Yeah, how do we know it's a conditional statement? Yeah, it's conditional. It's got the if then. And so what we want to do is we want to identify the P and the Q. What's the P? It is Saturday. That's the hypothesis. That's our P. So I'm going to write a little P under there. And what's the Q? There is no school. There is no school is the conclusion. So there's the Q. There is no school. All right. So what's the inverse? What do we have to do to write the inverse?
Make it negative.
Make it negative. Negate it. So we have to add in some not. So we want to say the inverse is not P implies not Q. So how do we write that? So wait, we have to start with the P. So if it is not Saturday, so if it is not Saturday, then how do we do the not Q portion?
There is school.
Yeah, there is no school. No, that would be a weird statement, right? So if there is not no school, that would be then there is school. Then there is school. All right. If it is not Saturday, then there is school. So we're negating the no. And the opposite of not no school would be that there is school. All right, truth value, true or false? False, why? Yeah, so false, Sunday is an example. All right, that is our counter example. All right. Converse, what's the converse do? Switch. So for converse, it's Q implies P. So the converse, how should we write that? If there is no school, then it is Saturday. Very good. So all we had to do was swap our P and our Q. So Q first, then P. Truth value, is it if there is no school, then it is Saturday. True or false? False. Why? Sunday, yeah. All right, again, Sunday is a good counter example. Oh, wait, what's the contrapositive? All right, so yeah, we got to negate the converse. So it's not Q, then, or implies not P. So we got to insert some knots on our converse. So what should we write? If there is, well, there's already a knot there. So if there is school, if there is school, then it is not Saturday. All right. True or false? True. All right. Yeah, if there's school, it's certainly not going to be on a Saturday. Oh, unless you've got Saturday school. Sorry. Yeah, I know. It's not a thing anymore, but it used to be. Okay, great. Let's do one more, and then we'll call it. Okay, number 10. If the product of two numbers is odd, then both numbers must be odd. Is this a conditional statement?
Yes.
Yes, it is. How do we know? It's got if and then. So we want to identify the P and the Q. The P is the product of two numbers is odd. What's the Q? Both numbers must be odd. Okay, what's the inverse? Ooh, interesting. Yeah. So, to negate the inverse, we have to negate the P and negate the Q. So the order stays the same, but we have to do the knots in there. All right, so if I were to say, if the product of two numbers is not odd, what does that mean? If it's not odd, it must be even, absolutely. So if the product of two numbers is even, all right, then both numbers must not be odd. How do I change that around so it makes more sense? Then both numbers, she has written cannot be both odd. Then both numbers must be odd. Cannot, then both numbers must not be odd. Okay, that works. Then both numbers must not be odd. All right. Ooh, if the product of two numbers is even, 7 times 8 is 56. Okay. Then both numbers must not be odd. True or false? No. Let's see. 7 times 8 is 56. If the product of two numbers is even, so there's my product is 56. Oh, you can't see that. There you go. So there's our product. It's even. And both numbers must not be odd. All right, yeah, both numbers are not both odd. All right, that's true. Interesting. All right. Sometimes these get hard, and I don't like that. All right, how do we do the converse? What do we do for converse? Switch. So Q implies P, so we're going to write what? If both numbers are odd. Oops, if both. If both numbers are odd, then yeah, I can just say their product, and what you said is also fine. Then their product is odd. If both numbers are odd, then their product is odd. Okay, so let me see here. So if both numbers are odd, give me two numbers that are odd. 7 and 7. Okay. 7 times 7 is 49. Let me do two different numbers. So 7 times 9 is 60. 1 and 1 is 2. Yeah. All right. So 7 times 7 is 49. That's odd. 7 times 9 is 63. That's odd. 11 times 9 is 99. That's also odd. Does this seem true or false? Seems true. All right. All right. This seems true. All right. And then the contrapositive. What do we do for the contrapositive? Yeah. So switch and negate. So not Q implies not P. So I always like to write this stuff down. It just really, really helps me. Is this a good thing you might want to have on a note card? For sure, right? Just to keep them straight. Hopefully when converse talk will help you remember what is what, but it's a good thing now. Okay, so the contrapositive, all I have to do is take my converse and add in the nots. So let's see, if both numbers are not odd, what does that mean? Yeah, okay, so if both numbers are even, all right, then their product is not odd. What does that mean? Then their product, oh, there's an R in there. Product is, again, not odd means even. All right, I like that. I like the translating there. That's really, really helpful. Okay, if two numbers are even, if both numbers are even, okay, so for example,
4 and 4.
Oh, give me two different numbers. 6 and 8, okay, and 6 times 8 is 48, so their product is even. That's true. Give me another.
4 times 2.
4 times 2 gives me 8. That's an even. And, all right, and 12 times 10 is 120. That's also even. Okay, so does it seem true or false?
True.
Seems pretty true. All right. So, always good to think through those a little bit. Do you have any questions for me? All right, you guys have a little Delta Math to do. It should go real fast. Whoops-a-daisy. All right. All right, super.